start the presentation. Hi, everyone. Today we talk about reactive programming in Java, the first steps in reactive programming in Java. I am Kamila Oliveira. I am backend developer at Chami Digital. I am also Microsoft MVP in developer technologies and community organizer at the Makers Code and Perifa Code Brazilian tech communities. And I also be book co-author of the book Jornada Java. So first, let's define what is reactive. Reactive. Reactive paradigm is a programming paradigm oriented to data and event flows as well as synchronous. Because it works asynchronous, is recommended to handle large data that undergo major changes in the real time, for example, social networks, mobile applications, and streaming applications. The most successful programming is Netflix, that have many requests, for example. So it's an example case. Reactive paradigm is also widely used in social networks, front-end and backend, because it works oriented to user actions that result in events. One of the principles of reactive programming and reactive paradigm is the reactive manifest. Reactive manifest has 4 principles that are responsive, resilient, elastic, and message-driven. Responsive means that the system responds in a timely manner, if possible. Resilient, the system remains responsive to failures. Elastic, the system remains responsible in the face of a variable workload. We can have 1 request or 10 million requests. The systems must stay responsible, elastic, and resilient. Message-driven, reactive applications rely on a synchronous message to establish a boundary between events, ensure flexible compute, isolation, and transparency in the application. We have some frameworks and libraries in reactive programming in Java. The first is reactive. reactive is an implementation for the reactive extensions JVM, which is a synchronous and event-based library that works with observable sequence. It extends from the observer pattern. Observer pattern is a pattern that have each object called subject of dependence observers that are automatically notified to each change of the state through data operators and methods. reactive supports data sequence and events to compose your event strings in a declarative way. We have some components in reactive and reactive programming also. The first is a map. Map transforms items emitted by observable by applying a function to each item. And we have an example of a map operator. For example, we have the observable.from, then have the letters variable. We apply the map function that converts this to uppercase, and we have the result for the variable in the uppercase. We have another operator that is scan function to each item emitted by observable sequentially and emits each successive value. Scope operators, we have another example. For example, we have the array of strings and letters. We have J, A, V, and A. We do an observable from letters that makes a scan from this, and we return a new string builder and append this in this way. We have another operator that's filter. The filter operators emits only those items from observable that pass a predicate. And we have another example of the filter operator. We also use the observables. You can see this. Observable from numbers. We have a filter of this and made a subscribe. After I will define what subscriber and subscription. And the reactive strings. That is the base of Java in the reactive programming. Reactive strings, it's an initiative to provide a standard, a guide, and a set of rules for asynchronous flow processing with NIO, that is non-blocking input and output backpressor. Reactive strings has some interfaces and methods. The first is the interface flow publisher that contains methods to produce strings and other events in the application. And we have an example of the interface publisher. And we have just one method in the interface publisher, that is the subscribe. So publisher publishes some events, and we made the subscribe from this event for a subscriber that will read this information produced by the publisher. And we also have the interface flow subscriber. This interface contains methods for receiving strings and other events for our application. In the interface subscriber, we have 4 methods. We have the onSubscribe that indicates an action that will be done when subscribed in your variable, in your class. OnNext indicates the next step that will be done with the result of some item, or some action, sorry. OnError indicates that will be done, will get some error in the application. Complete, when you finish some action that passed from the onAction on subscriber, we will do some action when we pass this operator, this method, on complete. We have other interface subscription. In the interfaces flow subscription, we have methods for linking publisher and subscriber. Subscription is a connection between the publisher that produces some information and the subscriber that reads, that receives the information from this publisher, these events, this data, these strings that is produced by the publisher. The subscription is the connection between these two objects in the reactive programming. And the subscription interface, we have 2 methods. We have the request, that you request a new subscription between the publisher and the subscriber. And we have the cancel method that cancel the subscription, cancel this relation between a publisher and a subscriber. We have another interface, that's the interface flow processor. The interface flow processor is responsible for defining methods to do some advanced operations, like transform items from publisher to subscriber. The processor interface is responsible to make this conversion from a publisher object to a subscriber object, and to subscriber to publisher and other. The interface flow processor don't have any methods. This just extends from flow subscriber and from flow publisher. And the last, I think the last class from the reactive strings is the submission publisher that implements the flow publisher, that is flexible with item producer according to the reactive strings. Reactive strings is a set of rules, that's many rules and many codes and many operations in them. I just bring some of them because it's many information about reactive strings. This is the simplest way of explaining the reactive strings. In the class transform processor, extends the submission publisher and implements the flow processor that I already explained in the previous. And reactive strings, what is the mission, the objective of the reactive strings? Reactive strings stand for runtime environments in the JVM, as well as network protocols. You can see in detail of them in the reactive strings JVM GitHub. The main objective of reactive strings is to define the exchange of flow data through an asynchronous. So all library that use reactive programming and in Java or other language is based on reactive strings. Is a set of rules that all languages must follow when you are working with reactive programming. Reactive programming is the scope to find a minimal set of methods, interfaces, and protocols that will describe the operations and entities necessary to have asynchronous data flows with NIO that is non-block input and output, backpress. And we have some reactive programming concepts that I talked about, observables, publisher, subscriber. So now let's see what means each of these publisher, subscriber, and observable, and others. The first concept is backpressor. Backpressor is the resistances or strength that oppose the desired data flow through the software. It's a feedback from the receiver to the producer or for the subscriber to the publisher that he is not supporting the load. A string is a sequence of objects that support various methods that can be operated to produce a result. Strings linked to a data source are strings capable of emit 3 events. We have the onNext event that represents some value that go to the next value or next step in a list. OnError, that there was an indication that you are on error in the execution. OnComplete, in the case of finish event, indicates that finished the list of events or the list of steps of actions. A flux can emit from 0 to n events, passing through onNext, OnComplete, and OnError. And here we have an example of the timeline of flux from the left to right. So in the example, we can see we have 6 elements, 6 objects that pass from this operator. This operator can be a map, a scan, another operator that uses in reactive programming. Sorry. This box indicates the transformation that the operator performs in the flux. And after pass for this operator, these objects have results in a transformation. And if we have some error, then we produce OnError in the end of this action. And we have the mono. The difference between flux and mono, that mono can be emit just the 0 from on one event. In the flux, we can emit 0 to n events. And mono also can pass from OnNext, OnComplete, and OnError. And we also have the represented, the image is not in a high definition. This is a mono timeline from the left to right also. We have one item issued by a mono that also passes from some operator. This box indicates the transformation that the operator performs in a mono and results some transformation. And if we have some error, we'll return OnError. And we have some finished data, we will return OnComplete, some action after this. An observable can pass messages synchronously. A subscriber or a receiver, as I was saying in previous slides, consumes the data received from a subscription. A publisher produces the data that will be the subscription. And a subscription is a connection between subscriber and publisher. And here we have some example of this flow of this process. We have the publisher that produces some data and send events to the subscriber that consumes the data. The backpressor is the response of this subscriber. It's not able to process this message. For example, we have producing million of data, million of strings, and the subscriber cannot read this information. And we use this backpressor to send this feedback to the publisher to make this load balancer and work with other threads or other alternatives with this information. A code observable, we have code and hot observable. A code observable is the sequence of events. It's only executed if observable has an associated. And a hot observable broadcast events regardless of whether that is an associated. Area socket is a binary point-to-point communication protocol intended in distributed applications. Area sockets enable the following symmetric interactions model using a sync message passing over a single connection. We have a request response that is a string of one information. Request to string that is a finished string of many. And we have a file for that not have any response. And bidirectional strings. Area socket supports the resumption of the session that allows the resumption of a long-term flows in different transport connections. R2DBC is the relational database connectivity that brings reactive programming's API to relational database. R2DBC is also based on the reactive string specification that a set of rules is a guide of reactive programming. R2DBC provides an open specification and with R2DBC we can work asynchronous and with NIO, work with relational database, supports the scalable. And finally, Spring Web Flux. Spring Web Flux is the most used framework about reactive programming in Java. Spring Web Flux can be defined as a parallel version to the already known and widely used Spring MVC, the servlet API, and having as main difference the support of reactive and IO strings, and supporting the concept of backpressor with the net server, coming by default embedded in this architecture. In WebFlux, instead of using the Tomcats and the servlet container and other components to the servlet API, we use the net server. We have this net server embedded in the architecture of Spring Web Flux, but you can also use Jet server or Undertown server. Spring Web Flux, from version 5.0 of the Spring framework, we have a reactive part in addition to the servlet structure that already exists. And each module of this is optional. You can use the servlet part, the reactive part, or even both in your application can make a mix of the reactive structure and the servlet structure, or use it out of reactive or out of servlet. This is the stack of Spring Framework that we have the servlet container that has these components, the servlet API, the Spring Web MVC, and work with controller and request mapping. And in the reactive stack, we have the Tomcat, the Jet, the Net, and the Undertown servers. Instead of working with the servlet API, we have the HTTP and reactive strings. And instead of working with Spring Web MVC, we work with Spring Web Flux. And instead of working with controller and request map, we can use router functions. In the example that I will show in the end of this presentation, controller and request map with Flux, I don't use the router functions because it's so complicated to change in the beginning of working with Spring Web Flux. So I use all these components and controller and request mapping. I made this mix of the two. Spring Web Flux was developed because we need non-blocking application that could work with a small number of threads, and that could be run with some high source. In the servlet 3.1, an NIO API was provided, but its use does not correspond to the rest of the API. That a servlet API is blocking in your definition, and NIO API is the opposite of the servlet contract. These factors were decisive for the development of a new API that was used independently of the execution time and in a non-block way. It was possible with the servers Net, for example, or Net, Jet, and others that consolidated themselves in the asynchronous and non-blocking operation. Another that Spring Web Flux makes it easier to understand the user the concept of functional and reactive programming with the addition of Java 8 functional features and the Flowable API reactive strings in Java. Enable Spring Web Flux to have functional endpoints and annotated controllers in your applications. And how requests work, what is the flow steps for a request is processed. In this model, in the Spring MVC model, depending on the volume of a request and the way it was developed can cause a slow application and even out-of-memory error. This type of error usually occurs when we keep objects for a long time or try to process data. And what steps contain the process of request? The user made the request. The request, pass for the servlet Tomcat that has the thread pool, pass for the dispatcher servlet, pass for the request mapping, and after to the controller, after to the service. After made some database operations, a get or a post operations, and for finish, return some response. On AppFlex, we have different process. We have call the data, and we have some on action, on error, or on complete result, and returns the data. And we have the user made some request that pass for the net NIO, pass for the event loop in the net server, pass from the reactive strings adapter, after pass for the dispatcher handler, and after from the functional endpoints, and return this response for the user. We have famous and most used library in the reactive programming that I use on my work, that is Project Reactor. Project Reactor is a library based on reactive strings specification. It is completely non-documented and interacts directly with the functional Java API using string, duration, and completable feature. For composing elements using Flux and Mono. In microservice architectures, offering backpressure mechanisms ready for TCP, UDP, and HTTP, including WebSockets. Its operators and schedulers can support a large transfer volume up to 10 million requests per second, according to Reactor documentation. It was also the first reactive library suggested by the reactive strings applications, which were later also implemented by React Java 2. Reactor modules are abstracted and interoperable reactive flows to facilitate and can be used with Spring frameworks, drivers, and client, for example, Cloud Foundry, Java Client. In protocols, for example, R2DBC and RxSocket that I already explained in the previous slides. We have three components in the reactor. We have the reactor core, that is the main part of this library. The other modules depending on the reactor core. Reactor core provides reactive types that implements a publisher that provides Flux and Mono. Reactor Net is the server for our NIO application used for developing highly scalable servers. And now I have some change my screen for the other screen. Just a moment. Let me check. All right. Let me just increase the size of the letter. So this is a very simple example of reactive programming. I will explain what dependencies I use in here and what steps I used for made this CRUD using WebFlex. So what's the difference for a Spring WebFlex application from a Spring MVC application? First is the dependence. For example, instead of using the Spring Starter Web, if I not forgot, we use the Spring Boot Starter Web Flux that contains the net embedded and other factors. Instead of we used how can I say, a blocking driver for database. In this application, I'm using MongoDB in a Docker container that is already running. I used a reactive driver for MongoDB that for all databases, I think, we have a reactive driver. So we have this the dependence Spring Boot Starter Data MongoDB reactive. Other dependence that is exclusive of Spring Web Flux is the Spring Doc. We have the Spring Doc for Spring MVC, and when we use in Spring Web Flux, we need to use the Spring Doc OpenAPI Web Flux UI. For tests, we have this embedded reactor test that has a for testing reactive applications. So let's go see the code. First, let's talk about the model. The model doesn't have many difference for a Spring MVC example. Now here we have a class that's a model, a table of speakers that have the fields ID, name, and stack. We have some constraints here. Another is the repository. In repository, we have some difference. For example, we extends from the reactive Mongo repository that have some methods that have insert, find YAL, and others methods. Reactive Mongo repository extends from reactive sorting repository and also extends from the reactive query by example executor. You always see the reactive word in this dependence. And the class that has some details that I need to explain is the controller. Here I'm using REST controller that is part of the servlet API. I made this mix. In my work, I use a REST controller instead of router functions, but using Webflux, so I can use this servlet and Webflux in the same time. So let's talk about the structure of this class. We have the flux and the mono. For example, when I have a point that return all speakers, that is a speaker CRUD, that return all speakers, how I am using 0 to n speakers, many speakers in this endpoint, we work with a flux. Is when I use in a post that I am just creating one speaker, I use a mono. When I am getting by ID that I just return one speaker also, I am using mono. Delete, I also using mono. And when I work with strings that return the data in other format that not is JSON, is other format, we work with a flux because it's a flux of various speakers. Let's see if this demo is working. I have some minutes to the end. Yeah, it's working. Okay. I think I don't have a speaker created. I will share the Postman screen now. Okay. So let me change this screen. Okay. Here we have the Postman. The application is running in another window here. Let's try to create some speakers and get these speakers. Request. It's a post. We have a body. Let's part 8080. Let me check the field names. We have a name and a stack, right? Name Kamila. And the stack is Java. Let's see if it works. I hope that works. And the request. Oh, HTTP. Not found. Let me check. Speaker. Let's try again. Yes, I created a new speakers. The ID is auto-generated with the name Kamila. So I call this create endpoint. That is a mono because we just can create one speaker. Let's get this. Speaker, sorry, right. Let's send the request. Let's create other speakers. Let's try define by ID. This ID. Is working. I will share the repository with you on the end of event. Get, but delete. Let's try the delete endpoint. Okay. Let's create other. Just to show how a string returns the information. Women text speaker. Right. Let me check what's the endpoint of string. Remember that is a flux of string. We have various speakers. Strings of speakers. Let me try. Oh, speaker. The difference between a get using JSON and using a string is that in JSON, I change this. Let me delete this ID to bring the other speakers. In JSON, we have the data returned in this ways with this JSON format. And when you're using a string, the return is in other formats. Let me check when. How can? Yeah. Not shows. The response will come with this data on the beginning and have this other format of response. Not have the same. We don't use the string in the work generally, but it's a way to show what contains in the string. In string is a main component of reactive programming. So just for curiosity, and showing how a structure of strings. Strings are another type of return. Oh, sorry. Strings don't work with application JSON, and that's this media type, text event. So let me return to the presentation. Right. Just remember things that I use in the example at Spring Boot Starter Web Flux and Spring Boot Starter Data MongoDB Reactive. In this repository, the main difference that extends from reactive MongoDB repository. In the endpoints, the difference and story of using response entity or just the name of some response class, we must pass that if the return of the response of this endpoint will be a flux or a mono. And what are the benefits of reactive programming? Reactive programming is non-blocking, which generates a certain performance gain. Reactive programming works with fewer threads, less used, and spend memory. Reactive programming follow the principles of the reactive manifest. Just remember responsive, resilient, elastic, and message-driven applications. And what the problems, because nothing's perfect. The problems is a different form of programming, is a declarative way of programming. Mainly if you're using outer functions, you will see many differences from the normal way of programming Java. And you need to learn another forms of work. You need to learn all this base of reactive programming when you are working with Webflux. So sometimes we don't have sufficient time to learn a new paradigm in the work or other situation. So it's a problem of reactive programming, in my opinion. Another problem is the way of the errors are informed, because the debugging and the stack tracing of Spring Webflux is many different of Spring MVC, so it's another problem. You need to learn how to analyze errors and stack traces in another way. But other topics is just benefits using Spring Webflux. Here I have with some reference that I use in this presentation. I will share the slides with the organization and in my social networks after this. And here we have my LinkedIn profile and my Twitter profile. Feel free to connect, to talk about reactive programming or other topic. And thanks for watching, and thanks for opportunity to stay here.